Our first practical involves finding the concentration of a hydrochloric acid solution. Well, we're going to begin by making a primary standard solution. I'm going to obtain 13.25 grams of solid anhydrous sodium carbonate. I'm going to weigh that using an electronic balance. So I'll switch the electronic balance on, and then I'll place the container upon which I'll put the solid anhydrous sodium carbonate. Now that container, that dish, weighs 42.11 grams. But what I do is I press the tar button, the T-A-R-E button, and I set that mass to 0. And then I put the powder on there, and I put powder on the dish until it has a mass of 13.25 grams. That's solid anhydrous sodium carbonate powder. Anhydrous means, of course, there is no moisture, there is no H2O in that powder, hopefully. And then I get a 250 cubic centimetre or 250 mil volumetric flask. Using a funnel, I put that powder in the flask through the funnel, and then I fill it up with water up to the 250 mil or 250 cubic centimetre mark. And you've got to put the stopper on that and shake it up really well and try to dissolve all of that powder, all of that solid. Now, the mass of sodium carbonate that I used was 13.25 grams. The relative formula mass of sodium carbonate is 106 grams per mole. So the number of mole of sodium carbonate, where the number of mole equals mass over relative formula mass in this case, the number of mole of sodium carbonate is 0.125 mole. And that's how many mole there is in the 250 milliliter solution, in all of that solution. So then what I do is I grab a pipette and I obtain a sample or an aliquot, a 250 mil sample or aliquot, and I remove that using the pipette. And the 250 mil aliquot or sample is transferred to a conical flask. So now I've got myself a 25 mil sample. I'm going to calculate the number of mole of sodium carbonate in that aliquot, in that sample. Now, only a fraction of the amount or mole of sodium carbonate from the volumetric flask is contained in the sample. Now, remember that I had 250 mil of solution, but I'm only using 25, only a fraction. So I say 25 over 250 multiplied by 0.125. That's the total number of mole in the volumetric flask, but I only want a sample of that. And the number of mole in the conical flask, the number of mole in the 25 mil sample, well, I've only got 0.0125 mole of sodium carbonate in the aliquot, in the conical flask. Well, the next thing I do is I fill the burette up with hydrochloric acid solution of unknown concentration. Well, I get that initial reading and the initial volume. Well, that initial reading is 10 mil. That's just the initial reading. I get my conical flask with the aliquot or sample, and methyl orange, the indicator, is added to the conical flask, and the solution will probably turn into a yellow, have a yellowish sort of color. And I place that conical flask under the burette, and I slowly add the hydrochloric acid solution to the flask. I turn the tap on, and the acid flows in there, and I keep on adding acid until the solution turns a soft pink. Not red or a strong orange, but a soft pink. And that final reading, well, the color change, of course, indicates that the end point has been reached. And I obtain that final reading, which is 33.45 mil. And I get the difference between the two readings, final minus initial, and that's 23.45 milliliters. That's the amount of hydrochloric acid solution that was added. And so the titre is said to be 23.45 milliliters. But let's get a balanced equation for that reaction. Well, the sodiums don't balance out. I've got 2 sodiums on the left and only 1 on the right. Well, that's easily balanced. I just simply double the amount of sodiums on the right. Now the sodiums are balanced, but now the chlorines are unbalanced. I've got 2 chlorines on the right and only 1 on the left. Well, I put a 2 there, and now everything balances out. The sodiums, the hydrogens, I think everything there balances out. The chlorines. And I'm adding the states there. So obviously the sodium carbonate is an aqueous solution, for example. Now, the ratio of mole of sodium carbonate that reacts with the mole of acid, that ratio is 1 to 2. That's the ratio of mole between the carbonate and the acid, 1 to 2. So if I know the number of mole of carbonate in the conical flask, how much acid will I need? Well, I'll need to get that 0.125 mole, which is the amount of carbonate in the conical flask, and because of the ratio, I need to multiply that by 2 to get the number of mole of hydrochloric acid that reacted in the conical flask with the sodium carbonate. Now, we noted the volume of hydrochloric acid used. The titre was 23.45 milliliters. Well, that's the formula to work out the concentration, number of mole over volume. And the volume must be in litres. So I convert the milliliters to litres, dividing by 1,000. And now I'll work out the concentration, that total number of mole divided by the volume in litres. And I get 1.066. That's the concentration or the molarity of the acid. And that's what I was meant to find. That was the purpose of the prac, to find the concentration of acid. And I round that off to 2 significant figures. So I have finally achieved my objective. Thank you for watching.